earlier on this semester, we were talking about simple interest in our word problems that we did. Our simple interest formula, I equals PRT, means you get interest at the end of a set time period. You receive or pay interest, and that's it. Okay, one time on one lump sum, and that's all. When we talk about interest being compounded, this is money that we maybe have in a savings account or a CD. Maybe some of our loans are figured on compound interest and not simple interest amounts. When the interest is compounded, that means that as time goes by, you earn interest on not only the principal that you put in, but also on the interest as you leave the money there. And so, pause for a coughing fit. So the formula is a little bit nastier, and it's something that we couldn't deal with before we got into this chapter. Our compound interest formula looks like A times equals P times the quantity 1 plus R over N all to the NT power. Okay. So the P here, instead of calling it principal, we call that the present value. That means that's the amount of money that I walk into the bank with today. Our R is as it has been in our other formulas, and that's our interest rate. Now make sure always you turn your rates into decimals. Okay, oftentimes they will be given as percents. If we know the percent, we're not going to plug in 5 for 5%, we're going to call it 0.05. Almost never will you put the actual percentage into a formula as it's written. You need to be able to convert them into decimal form. Okay, the N that shows up in the denominator here and up above, that is the number of compounds per year. Compounds per year. And so if we are told that our interest is compounded monthly, monthly means 12 times in a year. Okay, maybe it says annually. That means, ooh, there's an A there. It means only one time each year. Maybe I get quarterly bank statements at my bank. Quarterly means 4 times per year. So those are our values for N. And T, squeeze him out here, as it always has been, T is time. Now, in the other word problems we're going to do here in one of the next videos, our time can have any units. It can be in days or weeks or months or years or decades. But time in an interest problem is always in years, just like it was with our simple interest formula. Time is always time in years. So 4 means 4 years and 6 means 6 years. And if you only want to leave your money there for 6 months, you would use 1/2 or 0.5 for your time. If we start with this much money earning this interest rate compounded this many times per year for this many years, then at the end of that situation, the A, the amount that's there, is what we call the future value. Okay, so I'm going to try my hand at typing here so I can get things done a little bit more clearly. Okay, let's say that I have $4,000 and I want to invest that in an account that earns 3% interest. Let's told my money is compounded monthly. I want to know how much I'll have at the end of 9 years. Okay. So I walk into the bank today with $4,000. I'm told that I can earn 3% interest on that. So if you find that bank, you let me know, because that's hard to come by anymore. Okay. I know that my money is going to be compounded monthly, which we said means 12 times every year. And I want to know how much money I'm going to end up with at the end of that amount of time. So if I'm looking for the future value there, I'm looking for A, which means I should have numbers I can plug in for the rest. Okay, 4,000 is my present value. That's how much I'm handing them at the bank. My interest rate is 3%, and so I know I always need to write my percents as a decimal. So I'll slide that decimal 2 places to the left. Compounded monthly means 12 times every year. The 12 goes down below and up above. That says 12 there, not R. And my amount of time that I'm leaving that is 9 years. If the future value is what you're after, then there's no algebra involved here. It's a matter of asking your calculator the right question to see how much is going to come out. So go ahead and pause the video for a minute and type that stuff into your calculator and see what comes out when you're done. The future value you should find from that situation is you should get $5,238.09. If you didn't, that means you pushed a button wrong in your calculator. If you got something closer to 40,000 instead of 5,000, I can tell you what you did wrong. Most of your calculators, and this is where it stinks that we're not in class together, because I can walk around the room and watch you push the buttons and show you what to do. Okay. Most of your calculators, you can just enter the expression in from left to right, pretty much as I have here. Okay. Again, if you got something closer to 40,000, 30,000, $37,000 instead, then here's where you went wrong. Okay. Understand that the exponent up here is that product, 12 times 9. So if you did not have the parentheses around your 12 and your 9, it raised this expression to the 12th power and then took the answer times 9. So you'd get a little bit over $37,000. Okay, both the 12 and the 9 are attached to this, so you can either wrap them in parentheses or do that product first and then just say, well, I'm gonna raise this to the 108 power. Some other things to try to stop you, again, since I'm not in class, to look over your shoulder. Okay, some students will try to distribute this 4,000 into both pieces here. Okay, that is not okay. And the reason it's not okay is because this exponent here is only attached to what? It's attached to this expression. Okay, the 108 is not attached to the 4,000, but if we distribute it in, then we're gonna get some huge amount of money, something I'd be very happy to tuck in my bank account, but not the answer that we're supposed to get. The other thing we have to be careful of is, and in this problem it's not a big deal, but some students try to do this piece first, and then my pen went right. This piece first, and then they round. Okay, don't ever round this value in here. Okay, don't ever round it. If it goes out to 12 decimal places, you need to hold it to 12 decimal places. If you truncate it to 3 or 4, you're going to have problems. Okay, so let your calculator just hold on to that for you. It can do that. You don't have to even write it down 1.000 blah 1 2 3 4 9 6 7 8. Okay. All right, when you turn the page, there's going to be a couple more of these, and you can try them at your desk, and then turn back on the video when you're ready. Okay, take a minute to, here's the problems. Go ahead and pause the video. When you come back, I will show you how to work them out. Okay, on the top one, the $2,500, that's my present value. My 2.75% interest. I move the decimal to the left 2 places and I get 0.0275. Quarterly means 4 times each year, and then I also am leaving it there for 4 years. So this 4 is this 4, and these 2 are because of the quarterly statements. Okay, go ahead, if you didn't have that, get that adjusted, pause it, plug in, and then see what comes out. Ooh, not blue. In the future, the amount you should have is still not blue. $2,789.64. Okay, if your calculator didn't give that to you when you plugged in this expression, you can give me a shout in one of my Zoom meetings and we can get it straightened out, or you can play with it till you get the request right, okay, get your notation right. On the second one, we are wanting to end up with $10,000 in the end. Not something that we're starting with when we walk into the bank today, which means our $10,000 goes here in the A. Okay, the interest rate is 8%. Compounded semi-annually means 2 times each year. We said I'm going to graduate from college in 4 years. So here's what we're after. And if I want to solve for P, then I'm going to figure out what this big mess is right here. I'm going to divide both sides of my equation by that. Now your present value should be less than $10,000 when you figure it, because it's what I'm walking into the bank with today, and it's going to grow to get to that 10,000. So pause it, plug it in, come back to me with your answer. That present value should be $7,306.90. Okay, practice some of these. These are actually found in section 4.2 of your textbook at the end there. But we need to practice these before we can move into some of the exponential growth and decay problems found in 4.6.